Welcome to Innovation Alley. This episode features University of Michigan's Glen Daigger for a discussion on the evolution of engineering.
Good morning and welcome to Innovation Alley. I'm Tim O'Rourke, Chief Technical Officer at Wade Trim. Joining me today from Wade Trim is my co-host Dave White, our wet weather practice lead. And we have a special guest with us today, Glen Daigger from the University of Michigan, formerly of Ph.D. And you're not new to Innovation Alley. We did a One Water podcast early last year. I guess that was season 2, right? Mm-hmm. And in 2 parts, and you had mentioned during that podcast that you saw an evolution or revolution of engineering, and we kind of teased us to say we should do a podcast on that because that's a major statement. But for those in our audience, why don't you spend a little bit of time giving your background and how you rose to get to this spot in your brilliant career, and then we can go into this really exciting discussion.
Great. So yes, my role here at Michigan, I'm actually a bridge. So the formal title is a Professor of Engineering Practice, but it's intended for a person like myself that's had a long career in practice, but has credentials that makes me credible in academia as well. So I've been a water practitioner through my career, but my undergraduate degree is in civil engineering. So I understand what a good bridge is. It has to be founded well on one shore, founded well on the other shore. So this role allows me to be an academic, but also a practitioner. I do continue to practice. So you got to be founded on both shores and then figure out how to bridge. So that's what I do. I did spend 35 and a half years with this little engineering firm called Ch2M Hill, which is now basically the water practice for Jacobs Engineering. Right. Grew as Ch2M Hill grew up, I grew up.
You grew up with them, right?
So I stayed there for that length of time because about the time I needed the next career opportunity to continue to grow, it was there because the organization was growing. So I began my water career as a wastewater person and was the chief wastewater process engineer for some time with Ch2M Hill, and then became the chief technology officer, right. As Tim is for Wade Trim over about a 20-year period.
And you were that when I spent 2 years at Ch2M Hill. That's what your role was when I met you.
Yeah,
right?
yeah.
I don't want to say how long ago that was. It was a long time ago.
It's been a while. But the chief technology officer, it's a great role, isn't it? Because you have people that teach you things all the time.
Well, and I know you're a brilliant guy, and I'm not stupid, but you can't know everything about everything that you're providing as a company. So you have to have an infrastructure around you that is tackling innovation as it evolves in the various disciplines, right? Yeah. And Dave's the right-hand person I have in that same quest, and we're really proud of what we've been able to kind of advance forward. But I will admit, I was a senior at Michigan State 40 years ago. Mm-hmm. Sorry, folks, 40 years ago. And I know that you probably graduated before me. I don't want to but the reality is we have seen so much evolution, development of engineers in general, but also our industry and technology. And that's why this topic of there's a revolution going on. We have a track record to be able to compare our careers to see, this is a little different than the other disruptors and changes and things we've seen in our 4 decades plus, right? Yep. And to be a professor or have the ability to see young talent developing from its origin and then having spent 30-some years in our industry watching young engineers become really good mid-level engineers, become experts in their field, and then ultimately thought leaders in the industry. You've got a pretty good paradigm of what you mean by there's an evolution or a revolution going on. You picked the word. I think I had heard revolution, but certainly something's happening. Mm-hmm, mm-hmm. And when we prepared for this podcast, you kind of broke it into 2 areas, right? Cultural and digital. Yep. Now, when I think of the term cultural, I think of human beings and people evolving as human beings, right? And digital is this whole technology disruptor that's colliding with human beings. And least that's how I was kind of looking at it when you brought that up, and I don't want to misquote you, but why don't you kind of build on that for our audience on how you see that as the two areas that you see this revolution occurring in, and then we'll dive into some of the details of both cultural and digital evolution and why it is something that we need to embrace and look forward going as an industry and as a profession, right? So you have the floor. And Dave, you can ask a question anytime you want.
Okay, great.
So I'll start briefly with digital, but then spend some time on the cultural side, because the digital is an enabler. So engineers used to spend a lot of time doing calculations, and the three of us were at the point where producing engineering documents was ink on mylar, right? And you had the drafting pools and so forth.
Mechanical pencils that you went through.
So much of that is because of digital is now automated. So the routine tasks are not do not need to be done by human beings. That actually frees up the opportunity to spend more time on innovation, spend more time on making sure that our solutions are tuned to what is needed for the world. And you can kind of put that into a sustainability framework of looking out for the environment, but also for the economy and for people, but also people's expectations. People being the public have a greater expectation that the solutions that we're providing to them, that they have a bigger say in what those solutions are. So the cultural evolution is in terms of the professional engineer. Professional engineer is doing engineering that solves people's problems. Focusing on solving those problems and interacting with people is a much bigger part of what we do as engineers, because the engineering it has become more automated.
Automated, and I've asked you this question before, and I think the audience might be interested in your response. Dave and I have a hydraulics background, closed pipe, conveyance and that kind of thing, and obviously hydraulic models have been around for, you tell me, Glenn, 30, 40 years. Well, we weren't using them in college when I was in college, but shortly thereafter.
Well, was it the Kentucky pipe method?
Yeah.
I learned that in undergraduate.
There's the first disruptor on. But we had to learn how to close the loop on the Hayes and William, all that. We understood the mechanics of actually doing the calculations, and that a result was a result, but it had to make sense because, you'd done it a number of times, and if your answer didn't seem right, you must have done something wrong.
Yep.
And I learned from another, when I got into this industry, the guy I succeeded at Waitrim, a guy named Mark Coleman, just had an intuitive feel for hydraulics. He did, and I learned it from him, and maybe it's just aptitude, but I know what an answer should be, plus or minus, and I'm sure you've got dozens of examples, hundreds of thousands of whatever. But I have seen young engineers spit out a result from a model, hand it over, and you've seen it too, Dave, and it's wrong.
Yep.
But not aware that it's wrong. And my always was, is that because you didn't learn from, you're relying too much on digital solutions versus it's just an aid to make something more efficient, to get you to where you got to go quicker, but you ought to know if the answer makes sense or not when it's spit out, right? Because these things don't always spit out a perfect answer depending on the parameterization you put into it.
Yep.
Right? But you had a really interesting answer. You said your young students do have the aptitude and do have the, right? I mean, that isn't a fear on your part.
Well, I think it's something that we, and it's not at the university. It's particularly important in the early years of
your profession.
That you have someone that will help to teach you that.
Mm-hmm.
What we're talking about is intuition, right?
Right, exactly.
But intuition is based on experience. It's based on data. So it's a matter of teaching folks how systems work, the understanding of the broader system. People differ in terms of how their brains work, in terms of how natural that comes to them and how unnatural it is for them. But anybody can learn it.
And experience too, right? I mean, after a number of years, you've seen it so many times, it's obvious that the result is right.
That's right. That's right. That's right. The good, the experienced practitioner, yes, knows generally what the answer is before you do the analysis, but that comes with time. So
it's like doctors and engineers. You don't want them to say, "I've never seen that before." That one's new to me. Whoa! How long have you been practicing medicine? But that is experience is irreplaceable. But again, the cultural thing that we were talking about earlier too is that the younger generations behind us, they all have their nuances and changes and differences, but there's a cultural change in solutions kind of being looked at, right? When we covered all this in one water, right, guys, with you got to look at the whole cycle of water, and there's things happening that, whoa, I haven't seen that before. 500-year storms happen in a week and a half. We haven't seen that before, which is driving a reaction to how do we as a culture, right, culturally, tackle these problems from an engineering standpoint, knowing that it's not something that's been around 100 years, that has been solved 50 times. Or whatever, 100,000 times. But so what are your thoughts on that cultural kind of viewpoint of the next wave of solutions?
So what you do see with an increasing proportion of the of the folks coming through the educational program is they understand that yes, the technical component of the work that they do is important, but that tying that to the
higher cause,
to actually solving important problems and problems that people care about, that's increased. So,
Glenn, do you see more passion from the younger engineers?
Passion is inherent, but it's awareness.
That's a better word. Right,
awareness of the of the issues of the broader world. So, digital. Let me come back to digital for just a minute, because what we're talking about is understanding the system, right? So, as engineers, we spend a lot of time learning about this piece and this piece and this piece, because to be a good engineer, you've got to understand how this piece really works. What models do is represent the system. So actually, digital helps the intuition part of it, right? Intuition is about what the result is going to come. A hydraulic model, what for these inputs and this output, that's about how the system functions. So, digital helps people to interact with systems much more quickly and much more completely than you would in real-world situations. So digital is also an enabler. The trick is to use it, and someone to help the engineer understand that what to generally expect. So you can get 10 years worth of experience in a much shorter time.
Exactly. Yeah.
But you have to have someone that says, that's just wrong, and help them to understand why it's wrong and what should generally be the answer that comes out of it.
I know that you guys have had at CH2M had those automation tools that could get you to a fulcrum point quicker.
Yes.
Because I can remember from my perspective and working on large programs, there's all this busy work that's got to happen before we actually start doing the cool stuff.
Yep.
Right? And this is about how do we take that busy work and shrink it to now we're using our brains for the innovations and the creative solutions.
Yes.
That a model is not going to create on its own.
No.
Right?
No.
And that's, we'll get into artificial intelligence in a bit, but that's, I think, why we got to look at it as a great enabler, not a replacer or a blocker or any of that, right? So, Dave, what are your thoughts on it?
Because I was just thinking. So, I'm excited to be here too, because I think 30 years ago today, I was in this room as a hydraulics TA for Dr. Stephen Wright. So, really excited to be back here at U of M.
Yeah, he was Stephen Wright was Sam
There is
Goldwick's.
He's led a lot of our key technical people at.
Did he remember
Retrem.
you when you saw him again?
Well, I haven't seen him yet, but yeah, not too many professors.
That's an inside joke, folks.
Not too many professors left here that I know, but I remember being in this room and kids were taking notes with pencils and like a trapper keeper, and I had chalk on the chalkboard, and we had slides to really get it exciting, right?
Yeah.
And folks had to work on some of the first Macintosh computers to create the code for the models, and so it's changed a lot with everything that's in here now. But I think about my first assignment coming out of U of M. I started with Wade Trim, and I was working on a stormwater master plan for a small community. And it was, all right, we have a scope of work, we have to solve the flooding, we have a guideline from the state, no flooding for a 10-year, wherever it was, and we had to do it as cheaply as possible. What is the cheapest answer to replace a culvert and clean out a drain and just get to that answer? And this idea of talking to people or the public was something that kind of came at the end. Like we had to go to this public meeting, we had to present our results, hope they didn't yell at us and just get out of there as quickly as possible and get our recommendation, turn in our report, right?
Yep.
So we didn't really involve them in this process. We weren't thinking about, well, what happens after the 10-year storm and it floods? Everyone's going to be upset, and how do you explain it to them? And things change, and so but that was the mindset.
Yep.
Get our scope done, stay in our box, get it done.
And as Dave knows,
minimal public input.
And you've lived. I've seen you go through it, and I'm sure you've been through it more than we have. But usually the people that show up at a public meeting aren't fully supportive of the job you're trying to propose to do.
That's right.
They're there to ask tough questions, and one of the challenges is how do you project the engineering solution in a method that they can fully understand the logic of and the benefit of.
Yes.
Because we get into engineer speak sometimes. You say, well, the hydraulic grade line obviously is not. What's that? And you start getting into a defensive mode where that's another big challenge culturally for engineers is you're communicating the solutions that are highly technical to a group that they're smart, but they don't have your background.
That's right.
You need to kind of come up with those common terminologies that they can, or analogies that they can understand, right?
Rather than hydraulic grade line, that water flows downhill, right?
Yes. Yeah.
Put it into simple but accurate. The trick is to put it into simple but technically accurate terms, right?
Yep. So that's all true. We had talked in preparing for this too about a lot of disruptors are going on, model-based designs and digital twins. And we've set up our organization to kind of take these disruptors, refine it to the point where it's beneficial for Wade Trim, and then implement it with investments from an R&D and innovation budgeting perspective. Last year, when I was at a technology conference, and Dave went with me on the one this year.
In Chicago.
But the year before was in New York City, and the big disruptor was digital twins. Who's going to replace her? And look, we're all aware that that's evolving, and it's going to be here as the norm fairly quick, and in many ways it already is. Nobody talked about artificial intelligence even 14, 15 months ago at that conference. A conference of chief technical officers, Glenn, in our industry.
Yep.
Let alone CEOs and COOs who are not more worried, but have the responsibilities of sales and profit and all that stuff that goes with running a business. This year, that's all they talked about. And you were there. That's all they talked about. And so we all did the crash course. All right, I know what it is. It's not brand new. We've all used AI in one form or another, whether it's voice recognition or other automation tools. But now it's being sold as something that could revolutionize and disrupt and replace our industry in some words, some views. So we've been kind of going through this disruptor, how to handle it and how to implement it correctly and efficiently for our client's base and for our base. And there's a fear out there from some of the younger engineers. I've actually had a young engineer tell me, well, you're old. You don't have to worry about it. You're going to retire and not have to win. This stuff could replace who I am. I said, no, it can't. And we started learning quickly, and I'd like you to talk about it, because you came up with the digital revolution, is that it is an automation tool or set of tools from the AI tree, if you will, but it doesn't think like a human being.
Yes.
It can be taught how to do things similar to what human beings do, more efficiently and quicker and standard, right? But it isn't going to, cognitive resolution of, if this problem exists this way here, a similar type thing over there, I automatically recognize it, and I'm going to also solve that problem without being told how to do it.
Yes.
Right?
Yes.
And so for me, it's okay that once you get that fear out of your way, then it's a powerful enabling tool to take our business to another level if we do it right and we get ahead of the competition in it, or equal with the competition. So I'd like to hear your views, because you're now dealing with it at the infancy level of students coming out of college dealing with it.
Yep. Yep.
Right? I mean, literally, we just said 18 months ago we weren't talking about it in our industry. Now it's the number one thing everyone's got to get on board with. So what's your thoughts with AI as a digital disruptor evolutionary tool?
So, it's a tool. It's a tool like anything else, so it becomes a matter of understanding what it can do and what it can't do. No tool has unlimited, capabilities.
Yeah.
So I as we were talking ahead, so I was actually in Taiwan last week at a meeting. It was actually a meeting about the innovation in the circular economy, but had a strong component of digital. So one of the keynotes was by a person who was one of the leaders in terms of AI and so forth. Facial recognition is what he worked on. Okay. But his task was to, in 30 minutes, describe machine learning and artificial intelligence to a bunch of water people. And he said, computers are good at two things. One is memorizing a bunch of data, and the other is doing calculations very quickly. So that's all that computers do, and they do that in response to the instructions that we give them.
You just did it in 15 seconds.
He went on then. Yeah. But he started, that was his recurring theme, and he went through a number of examples, and he went through some of the techniques and so forth. He actually described how you develop an AI tool that looks a little bit like a human being, but isn't. All it's doing is taking a bunch of data, calculations very quickly, and doing what we tell it to do. That's what all this is.
Yeah.
So no, they don't have consciousness and so forth. They don't have creativity. We can program them to do a lot of things, but what they do is they have access to a lot of and I stopped short of calling it data. I think data is something that we know is a real representation. They have access to whatever we give it, and a lot of it is bad.
Yeah.
I mean,
whatever's on the internet, right?
Whatever's on the internet, or whatever we give them access to, and so forth. They take that and they do calculations, millions of calculations very quickly, in response to the instructions that we give it.
The instructions. This is what I want you to do.
That's right.
I remember I have a young engineer, young talented superstar in our New York office, and I asked her to go into the Chat GPT and figure out the diameter of the flows. It was on a job we had. Mm-hmm. You know what the size of the pipe is. Figure it out. This is the slope. It's an RCP pipe. Use the N factor, but give all the Manning stuff. Mm-hmm. And this Chat GPT kicks out the answer, and it's D equals 80 feet. Yeah. That's off by, at least 10, 12, a factor of 12.
Yep.
So go back, and then she asked it a different way because something was missing, right? And then it gave the right answer.
Yep.
And to me, a AI robot can't come to U of M and pass all the classes and get a degree and then replace you as a human being.
Right.
It doesn't have the human causative thinking, I think, is what our expert we're bringing in to help us with this is the term he's using. That human beings can tie dots together that AI tools can't, intuitively. So, but I do see it, and I get back to that busy work, get rid of the busy work. And some of these powerful tools that were given to us as examples from this expert that we're bringing in to help us advance this initiative is, as architecture, building contractor would come in, meet with the client makes a couple of comments on what changes to make. I want that column over here, I want that column over here, I want to have that room changed. You used to have to say, okay, give us a couple days, we'll go and see what the impact of the floor plan is, and then we'll we'll come back and do the engineering evolution that we're talking about. I mean, the intuitive negotiating what we're going to do. This tool that they have is able to automatically move things around and recalculate all the beams and give them a cost estimate.
Yep.
Now the cost estimate is AAC class 5. It's not, detailed but it can give you comparative cost impacts based on formulas, right?
Yes.
And that's what you were saying is the power of their calculations being just, unrestricted. As good as we were with our, mechanical pencils, we're not, we can't go like that. And so to me, that's what I always wanted to see out of AI. Can we get the busy stuff done efficiently so our clients get what they really are paying us to do?
Absolutely.
Mr. Daigger, would you please solve my wastewater treatment issue because this is what's going on? And there's a ton of calculations that have to go on to do that. But intuitively, you kind of know where it's going to go, and you want to get those upfront busy things behind you.
Absolutely. Right? So I think it's, I'm sitting here thinking, we've gone through the slide rule to the calculator.
Remember the punch cards in Fortran?
Yeah. So we've gone through, and anywhere along the line, there were people that said, "Oh no, this makes it so much easy to do what I'm used to doing, so it means that I'm becoming obsolete." And quite frankly, that's a choice. Mm-hmm. You can choose to become obsolete.
You can choose to be obsolete, yes.
Yeah. But no,
if all you're doing are those busy calculations and you're comfortable with that and that's your job, and a tool can replace doing just that, then I think you might be a little worried. You need to evolve, right?
One of my colleagues he's from Argentina, so he's a native Spanish speaker. He was telling me in Spanish, the word for engineer means innovator. We tend to think of
Is that what it means in Spanish?
Yes, yeah. Yes. We tend to think about an engineer, it's the person that drives the train, right? So no, what we do is about innovation. It's about solving problems and providing better solutions. So these are all just tools.
Innovator in Spanish, because somebody once told me, just because I wanted to believe it, no, it means man of genius.
just a different way.
I wanted to believe it, but
it's kind of like Superman and the Man of Steel, right? It sounds better, but it's the same meaning.
Yeah. Well, Glenn, you made a comment that just spurred something for me that I remember slide rules too. I was taught how to use one. I was a young man, but I mean, a teenager probably.
Yes.
But to think that was, a few decades ago, maybe 50 years ago, 45, 50 years ago. Mm-hmm. And then it was used. But human beings have been around a long, long time.
Yes.
Right? We could debate on the origin of man, all that. But from an engineering's been going on well before the Roman Empire and all that. When you think that in the last 45 years we've gone from slide rules to what we were just talking about with artificial intelligence,
yes,
that accelerated pace of innovation, and then marrying that to human beings evolve, Darwinian, if you believe in Darwinian, they evolve slowly with selective process and all that. The brains don't turn on a dime as innovation is now. How do you see that those two things meet? The slower rate of human evolution to this accelerated explosion of technological evolution.
The other evolution.
Is that a big question? I mean,
no.
That's a big question.
No, it's an important question. But if you look at human beings, the other aspect of evolution is cultural. Mm-hmm. So it's linguists, people working with languages. They can go, for example, look at Spanish in this country, this country, this country, this country. The Spanish language, as it's been dispersed, has evolved.
Okay.
So, as an example, the cultural aspects of human life evolve all the time.
Yes.
That's the adaptation that we're talking about. And culture is an interesting thing. So, culture, to a large extent, is about expectations. It's about capabilities. After a while, you learn how to do certain things, in certain settings, because, how do we learn an awful lot of what we do from a day-to-day basis? We watch other people, and we try things, and we figure out what works for us, right?
Right.
I mean, that's when you learn to function in a given social environment, given work environment, and so forth.
Copy what's popular, try to be accepted as a group, and all, right? I mean, that's just normal human interaction.
Yeah, you see what people are doing, and you try this, and you find the things that evolution is. That is the evolution that has taken us from, over the last 40 years, over the last 400, the last 4,000. So
like a logarithmic, advancement of innovation.
Yeah.
And it's really cool. But when I think of all this, I'm excited about it, even though it's towards the tail end of my career. I would not have imagined 30 years ago you'd see the tools that we see now, doing the things that are going to make our business more effective, our solutions more thought out, because we're not wasting it on busy work. We're actually using our brain power to solve difficult problems that are happening.
Yep.
Right?
So you know what the skill of an engineer is? The skill of an engineer is to take something that could be quite complex, break it down into its pieces, understand the pieces and how they interrelate. So a lot of this fear of machine learning, AI, and so forth is because people don't understand it. Yes, there's detail as you do it, but the core of anything is actually, when you truly understand it, is not that complicated. What do we need to do with these tools is to break them down and understand what they can do and what they can't do.
What they can't do.
Where to use them, where not to use them. That's the skill of the engineer. So the potential, the potential is great. We've gone from the slide rule to the calculator to the computer. That's a great evolution.
And the computer itself has gone through exponential evolution. Right?
Yep.
So Glenn, are students at U of M or other universities now using AI to do their homework? Is that part of the curriculum now, or how are they?
Are you trying to get people in trouble?
Well, no, I'm just curious. Like, it's brand new. I know it's brand new out of the box. It's happening so fast.
It is. It's interesting. ChatGPT.
Yeah.
ChatGPT is folks are trying to figure out what to do about this. So I understand that, in fact, there are versions of ChatGPT that you can give a homework assignment to, and it will tell you whether it was done on ChatGPT.
Because you'll use AI to
check it.
QC AI, right?
Yeah. No, students are trying to, these tools are becoming widely available so quickly. People are trying to, both the students and the faculty and the administration are trying to figure out how to manage this. So it is. Students are also faced with. They know that they need to learn this. Folks like you and I, we've got young people that we can get to teach us, and so forth. But
go do that and give me an answer.
Yeah. But some of my graduate students, one of the nice things about being a professor is that you help a student to get started, but after a while they teach you. So
that's inspiring, I am too. I call them all kids now because we're old guys, right?
Yep,
and they're actually younger than my kid. So, but to me, I hope what doesn't happen with digital enhancement tools, and we could have done this podcast virtually, right? You could have been on a Teams with me, and Dave could have been in Cincinnati. I'm in New York, and you're here, and it would have been a great discussion, and people would have enjoyed it, but. I think us interacting as human beings on a table around this, talking about whatever this is so much more enriching when you're interacting as human beings.
And it becomes more important because it becomes more of the professional activity is doing that. Less of it is cranking stuff out. More of it is the interaction.
Human interaction and the collaboration and all of the great things that I've enjoyed in my career is the human interaction with digital tools, helping out. But believe it or not, this went fast. We're pretty much running out of time. And we could sit here all day and talk, Glenn, about a bunch of things with you. You've been our most frequent guest, right? This is number 3. So this did not disappoint me as far as what you meant when you said evolution of where it's going. And I think 10 years from now, we're going to be looking back and say, God, look at how far we've come in just the last 10 years, right? I think even more so than at any point. So Dave, why don't you give a couple closing thoughts, and then why don't you bring it home for us on this whole evolution, if they had one thing to remember or 2 or 3 things to remember, like that guy trying to explain artificial intelligence. I'll give you 15 seconds. But you know what I mean, kind of bring it home for us and our audience so that we can bring it close to the conversation. So Dave, why don't you give your final thoughts?
Yeah, so I just think it's a really exciting time to be an engineer, whether you're a student or you're in industry, because things are changing so rapidly. One of the things that got me so excited about engineering was this idea of a brainstorm. Like getting a group of people together to talk about a challenging problem and figure it out, and the energy in the room, and you're writing things on a board or wherever and trying to come up with ideas. But being able to do more of that with your team, your staff, the client, the public, and bring them into the process, I think speaks to that cultural shift of you need to hold on to that, because we've got some really powerful tools that are either sitting right here in the meeting that we can ask questions.
Yeah, I mean, Dave, to have a tool like that where we used to like break momentum because, well, we'll have to figure that out later because we don't. Someone's going to have to figure that out. You could get the answer immediately, and now the conversation continues into this accelerated problem-solving mode, which really takes brainstorming on steroids, right?
And I spent 6 months of my life decomposing hydrographs for that stormwater master plan, and I don't need to do that again. And if there's a button I can
decomposing
hit that does that, take them apart, the volume, I don't know, but there's a certain process we had to go through to look at the data. And if there's a way to help me do that quickly, get back to that master plan and talk to people about their houses and flooding, I'm all in.
And he's a powerful engineer, by the way, whether they remember him or not. No, I'm kidding. But so Glenn, why don't you bring it home for us, and then we'll call it a day.
Well, I'd say 2 things. So the first is don't be afraid, but you can actually, one of the things you can actually just get YouTubes and things like that. My students, when they need to understand something, just go get the YouTube now.
Yeah.
But, or find someone that is a real expert and can get you to that understanding of, here's what it is and here's what it isn't. So don't be afraid. That's point number 1. Point number 2, realize that it is more and more important. The professional side of what we do becomes more and more important. So just focus on being a good human being.
Well, that's never bad advice. So again, great guest, great discussion, Glenn. We look forward to maybe even coming with further topics with you because it's always fun. So with that, folks, this concludes another version of Innovation Alley. Have a great day. We'll see you soon.